Hey Internet, welcome to Superwits Academy channel, and my name is Anupinder Singh, and you are attending the webinar on the getting started with machine learning. So what exactly we have for this particular webinar is that we are going to discuss about the very basics of the machine learning. I've already posted the corresponding the content of the discussion, that what points we are going to discuss about. I thought of working it out in one single webinar, but with the scope getting for around 2 to 3 hours, so I actually made it cut short. So today's webinar will be for around 45 minutes, and I'll be only discussing about that how you can get started with it, what are different domains within this particular machine learning part, which could be the possible ways or path for you to get started with the machine learning. And then the subsequent one, which could be another webinar, or which could be the video which I can post you directly, in which I'll show you the deep down details, that with what are the different kind of tools that you can use, what are the different kind of what you call scripting language which you can use, what are the different kind of scenarios, domains, algorithms which you can use. So it will be in the another video as well. So there will be an extension to this, so that you can expect corresponding to this particular part. So, what will be the format of this particular webinar? We have planned it for around 1 hour. We will try to make it, uh, you know, of 1 hour only. So, what I expect is like we'll be discussing the topics for first 45 to 50 minutes, and during the discussion of the topic, if you get any kind of query, you can put in your comments in your chat section, which is just on the right hand side of the video. You can put your queries in that particular chat section, or you can put your queries in the comment section as well. So I'll be taking your queries and uh, doubts just after the discussion of this particular content, right? So this is what will be the general scenario. So you can think of that next 45 minutes I'll be sharing the very basic insights on machine learning, and some part is theoretical, some part is like I'll show you certain portal which you can utilize for the purpose of your learning on particular language, and a couple of more things, that what different activities you can do over there. So that is what we have for this particular webinar. So I am going to just start without any delay. Of course, if there is any challenge you find with audio and video, just make sure you tell me in comments, so that I can do some troubleshooting then and there, right? So let's get started. So this is what we have for today. So we are going to talk about the very basics of the machine learning, and moreover we are going to have the following set of agenda.
So this is the agenda for today's webinar. So we are going to discuss about the very basics of machine learning. That what exactly is this? Then we are going to talk about why there is a necessity of the machine learning, and what are the basic implementation processes which are there corresponding to machine learning part. This is something which is important for you. And then what are the different applications which are there for machine learning right now, and what could be the possible learning path for you or anyone who is a beginner to the machine learning, and who is just considering that, okay, let's see what exactly we are having for this particular machine learning prospect. So when you talk about the basic definition of the machine learning, what exactly we get is it's basically a field from the computer science that is concerned with programs that learn, and is also concerned with the questions of how to construct computer programs that automatically improve with experience, right? So when you say experience, it's something that when an execution happen and a corresponding result is produced, and that result as an experience has been learned by the computer program itself, so that whenever next time it is going to work around, it should be able to give out a better result. Now best example is Google Assistant that we are going using in our Android phones, or maybe Siri, which you might be using in your iPhones, right? The primary objective of this machine learning is, because there is a lot of data which has been generated by the different kind of application these days. So organizations are actually encashing on the data, right? So they use data to make decisions or predictions for the future prospects, right? So this is something which is important for them, because the data is huge and it's very, very difficult to do the analysis of that data in manual form. So they generate certain kind of computer constructs which are going to give them certain decisions based on certain set of input data, which could be a real time data, right? So you might be using a real time application, for example Facebook, for example YouTube, and they give you suggestion on the basis of what content you are accessing right now, right? So that is what you have corresponding to the predictions or making decisions on the basis of data. Another one is, it is going to learn to identify patterns, right? It's very important. Pattern is something which is there in your data, right? So without being explicitly programmed to, because we are not writing the specific program, we are not saying that okay, do step 1, step 2, step 3, step 4, and so on, for analyzing the data. It's the computer itself who is going to predict that okay, what way shall I be looking at that particular pattern, and then how I'm going to work around with it. We are going to look at the examples in the later part of this particular presentation, and then I'll try to connect that how the identification of the pattern is done by using different set of procedures, right? Now if we look at the big picture, machine learning is something which is a subset of artificial intelligence, right? So if we are having as an umbrella term artificial intelligence, machine learning covers a significant portion of that. And if we go specific to certain kind of niche based data processing, then it becomes a deep learning. Generally neural networks comes under this. Big data is something which is being processed by this particular framework, because data is something which is very important and very crucial to this particular artificial intelligence framework. And the data science, which is more or less stats, we are going to discuss in this particular part. So data science is out of scope of this particular presentation, but data science is purely based on statistics, and that statistics becomes a part of analysis of the big data, which is going to be processed through certain kind of procedures which are being designed by using the machine learning concepts or deep learning concepts or some other artificial intelligence based concept. Maybe some SVMs are there, some fuzzy logics are there. So that is what we might have under this particular big umbrella, but machine learning is covering the significant part of that. Now when you're looking at the different types, so generally when you are categorizing the machine learning, it is generally categorized in three things. One is supervised learning, one is unsupervised learning, and the reinforcement learning. Now, this supervised learning is something which requires a lot of data at the background, right? So it is actually going to take a lot of data and then do the prediction on the basis of that. This is also known as the predictive analysis that is being done. Stats gives you a lot of descriptive analysis that is being done, and then predictive is going to be based over and above of that. Data visualization is also done, but the supervised learning is basically some sort of task driven. You are trying to look at some data, and then on the basis of that data you're going to predict. So one of the simplest example that we can have is the real estate market, that from last 5 years, what is the trend, what could be the trend for next year, right? Or maybe next 2 years, 3 years, and 4 years, and so on. So this is one of the simplest part. Then second could be based on couple of parameters. We have, let's say, the mortality rate for the infants who are less than the age of 5, right? So there could be possible number of parameters which are available, that what sort of diet is given to them, what sort of immunization is given to them, what sort of care does they have, what is the family income, and all that stuff. And on the basis of that, because we have all these data with us, and we are able to predict that okay, for next upcoming years, if so and so set of categories are there, then what could be the possible mortality rate for the this category of uh, infants under the age of 5, right? So that becomes your supervised learning job. Whereas unsupervised is that, because supervised contain the class already built clusters, right? Unsupervised doesn't have those clusters. So you have to look at that how you create those clusters on the basis of the categorization of the data that you can make, right? So this supervised learning will definitely have some categories, whereas the unsupervised may not have the set of categories assigned. So first the categorization is done by doing some kind of clustering based technique, and then the prediction is done on the basis of that particular clustering. Now this is purely uh, uh, statistical based work, right? So you have to club 4 or 5 different kind of procedures to do the unsupervised learning kind of thing, and this is purely data driven task. You cannot have any specific type of task corresponding to it. Whereas when you talk about the reinforcement learning, the third category, the reinforcement learning is based on the learning from the error. So it is the next version of the unsupervised learning, and reinforcement learning is kind of iterative approach, right? So it's an iterative approach. It work on the things, it see that okay, what is the result, is it uh, correct, is it false, how much is the probability of correction, how much I can increase that probability towards the correct side of that particular solution, and so on. So based on that particular part, the iterative process works, and what is actually going to work for us the reward in terms of learning in this particular system. And this is a pure form of machine learning, right? So you can simply say that there are ways or procedures that are being put into this particular type of learning that allows a machine to learn on the basis of it. AlphaGo is the game which has been based on this particular reinforcement learning, and you know how popular the match was, which was won by the machine on the basis of the learning which it has done during that particular course of different sets with the world champion. So this is what we have in terms of the machine learning part as a three very specific categories, and they are not limited to it. We have other branches in between as well, but we need to look at the necessity of this machine learning first before we actually go towards that particular categorized part. So when we are looking at the necessity, why we are actually requiring, one of the biggest necessity for machine learning is increase in the data generation. The scale at which the data has been generated in past 4 or 5 years is actually comprising of the in total data which has been generated in past decade. And in fact it is more than that. So the increase in the generation of data is something which is huge, and it cannot be processed manually. So we need to find out certain ways so that it can be processed and can be used in terms of uncovering certain kind of patterns, certain kind of trends of in data, and so on, right? So one of the best pattern matching examples is the fraud detection, right, is the spam detection, and so on. So uncovering the pattern and finding the trends in the data is something which is done on the basis of this particular data which has been generated by the user almost every millisecond or second of this particular time, right? And there is a prediction that whatever the data has been generated in each year, next year will definitely go 2 or 3 times of that particular data, and storage is going to be the huge issue corresponding to that particular data. And the most important part is that how to utilize that data to uncover the potential that data is containing. So machine learning is going to help out in that particular part. And specifically if I talk about neural networks, they are one of the very frequently used tools for uncovering the pattern, and they are very specific tools for deep learning kind of thing, and they work around with a lot of different kind of potentials, right? So that they allow us to solve the complex problems corresponding to that. Okay, if a machine is trying to become a hand of a human, then in that case what could be the possible postures that it can be taking to pick up a particular object, right? So there have been couple of videos which has been released by the Google itself, because they have been working intensely in this particular field, and you can actually figure out that okay, if a object is to be picked out, then what sort of posture is required to first make a sideline of one object and then picking up that particular object which is under that the other object, right? So this is one of the particular complex kind of problem which can be solved. Apart from this, let's say the self-driving car. So at a particular point of time in a real time situation, cars has to make decision corresponding to Does the braking is required, does the acceleration is going to be given, or do we need to make a right turn, left turn, do we have to stop the car, do we have to overtake the another car on the road, do I need to make the lane changes and all. So that's kind of real time complex set of problem, and based on all these things the improved decision making will be there, right? So reinforcement learning is something which is there in support of the machine learning part, and a lot of different kind of necessities are there. I've just given you very few examples. There are a lot of more examples which are there, and very very specific use cases are there corresponding to the machine learning. So it is a huge field with a lot of potential, with different kind of use cases, different kind of applications that can have the utility of machine learning to improve its working. So that is why the necessity of machine learning is there, and it's very very important. Now, when as a beginner we are trying to work around with the machine learning part, these are some of the steps which we are going to look at. So I have actually two different variations here. You can see the particular numbers which are over here, the steps which are over here, is that you define the exact problem, that what exactly you're trying to work on. Let's say I am trying to work on a particular problem where I'm going to predict that, okay, how many students will be present for a particular type of session, right? Based on that, the data which has been available from past 100 webinars, right? So that is my problem definition, right? And then I'll be preparing the data that, okay, how many students or how many users the request is being sent, and how many users actually attended that particular webinar, from which particular background they were, which region they were, and so on. So I'm preparing the data, and from that particular data I'll be choosing certain set of columns out of it, right? So that is very very important, that I need to choose certain set of columns or certain features. We can say features, we can say columns, we can say attributes, whatever name you wanted to say. We are selective on the data. We cannot always use the full fledged data until unless it's very small. If we are working with a huge data set, we have to think of a very specific problem. We have to think of which columns are related to which attributes, columns, which features are related to that particular problem statement, and then we are going to analyze that particular data. So preparing the data or cleaning the data is something which is done. Then we are going to spot that which particular algorithm is applicable, and then we test on it. And during the testing we try to optimize and improve that particular algorithm based on the different parameters which are available for that particular algorithm part. So if you talk about the svm, or if you talk about the neural network, there are very specific parameters which you can actually change. Maybe the learning rate. If you talk about the neural network, the learning rate is one, the initial weights is another one. There is one very specific feature of the neural network, where how many number of layers will be there for a neural network, so that the particular processing of the data can be done, right? So there are a number of parameters on which you can improve, and then you can optimize corresponding rate. Now once you have the results available, in that particular case you are going to summarize your result, and this is one of the most important step, or you are going to tell the story based on that particular uh, solution which for which you are trying to find out, right? So the problem which you have defined in the first step, if you got a solution, and then what is the possible scenario that we are going to have. So let's say on the basis of 100 webinars I've looked at that, okay, the number of people who were actually been requested and attended, almost 10% people have a conversion with specifically IT and CS background, right? So if I have that particular data, I'll be able to do the prediction on the basis of it, and then I would be able to tell the story that why the people from IT and CS will be joining in this particular session, based on what is the domain of the session, based on what is the domain of the people who were sent the request, based on the prediction that has been done on the basis of, let's say, their demographic, age, gender, location, everything. So this is how the story is to be told at the end of every single process, right? So that is why we are actually doing this particular part, right? So the step which I have actually took is corresponding to the predictive analysis or the supervised learning method, right? Now why I've took this particular part for, because for the beginners this is one of the simplest way to start with. And before you run you have to start crawling or walking, right? So that's very, very important. Now another scenario which you can look at is, again, there are certain variation, but is almost similar to what we have discussed. So step one is gathering the data from the various sources. Step two is cleaning the data to have the homogeneity so that it can be processed by the applicable algorithm, then building the model by selecting the right ml algorithm. This step is very, very crucial up after this particular part, right? So choosing the data source and cleaning the data, because if the data has a missing values, it is not going to give you the exact results, right? So you also have to look corresponding to that particular part. So once you have the algorithm ready, you are going to get the insights from the model's results, right? Because you are going to push the data which has been collected from step 1 and step 2, and that has been pushed to the step 3 to the algorithm, and based on that particular push you are going to get certain result, and then you generate the data visualization which is going to be transformed as a result of the visual graphics or whatever the way you want it to do. So almost similar set of things, but maybe a little bit different approach corresponding to this particular part. Now, if you look at the particular applications corresponding to the machine learning, you can actually get a brief idea that how this machine learning is going to have the different kind of categorization. So we have supervised learning, we have unsupervised learning, reinforcement learning, that we have already seen in the types. But when we are talking about the supervised learning, these are the two primary approaches which are being done: classification and regression. So this is the reason why I've mentioned you that predictive or supervised learning we have took as a first step of implementation for a particular process, right? So when you are talking about the regression and classification, these are some set of examples which you can see. So population growth prediction that can be done using the supervised learning and by using the regression technique. So regression is basically nothing. We are having the data, based on that particular data we are going to see that what could be the possible outcomes that we are going to get by putting up a particular regression formula on that particular data, right? Based on what features we are using corresponding to it. Then advertising popularity prediction based on the historic data. So every supervised learning requires a historic data, right? Without that, it's not at all possible. It's history data which has been required. Otherwise, the supervised learning cannot be performed. Otherwise, it will go into the category of the unsupervised. So weather, market, and estimating life expectancy, this becomes your regression based problem implementations under the supervised learning technique. Whereas when you talk about the classification, we are actually having these kind of applications. One, we have identity fraud, one might be the image classification, computer retention, and the diagnostics. This is related to health, this is related to the marketing and business, this is related to some sort of you know, if you have used the Google Photos, you can have the faces recognized corresponding to each picture which you click, right? And you can give names to corresponding to that. Then identity fraud detection can is being used by Twitter a lot. So they have been into this particular part, and they have deleted a lot of Facebook is also into this, so they have deleted a lot of different accounts which doesn't seems to be related to any human, right? Or if their activities are not related to that. Now if we talk about the unsupervised learning, so dimensionality reduction and the clustering are the two primary uh, objectives for this particular type of learning. So feature elicitation, structure discovery, meaningful compressions, big data visualization, all this comes under the dimensionality reduction. So we are actually going to cut out on the set of features. Maybe we have 100 features, and then we are bringing it down to 30 or 35 features, and then we are going to work around that particular problem statement. Similarly, in the clustering part, recommender system, targeting, marketing, customer segmentation, this is what is being done. Facebook does it very, very well. LinkedIn does it very well. When you talk about the recommender system, based on your interest which are being provided into your profile, you get all these things. Customer segmentation is based on, let's say, if you are spending from your particular saving account, they can do a segmentation on the basis of what expenses you do, and then they start giving you the possible marketing related emails or messages or notifications and all that stuff. Targeted marketing is also from the same thing. So this clustering is very, very important activity under this unsupervised learning part. Then when you talk about the reinforcement learning, game AI, skill acquisition, learning tasks, robot navigation, and the real time decisions which are supposed to be taken corresponding to certain procedures that we have. So this is like self driving cars. This is for if you have seen the Boston Dynamic demo videos, they have this robot navigation related kind of implementation. So that's a reinforcement learning. Learning task is again like I've already given you the example of picking a particular object. That also comes under the skill acquisition. And the game AI, we have already discussed about the AlphaGo. So this is what is the, you know, broadest way to look at that what could be the possible implementations corresponding to each type of learning within the machine learning framework, right? And this is something which is quite interesting in terms of that. Okay, there is no limit to it. There is no limit to what set of problems you can uh, no implement through the machine learning construct. So it's up to you how you define that particular problem, how you utilize that particular corresponding data, and then which sort of algorithm you are using. It's not at all like that you are only going to use the existing algorithm. You may also create your own algorithm corresponding to it. So it's all up to the programmer that how they wanted to implement that particular machine learning related implementation process, right? So this is what you have in terms of your application. Now, next thing which comes into the mind of a beginner is that what could be the possible pathway that should be followed, right? So right now, if you are talking about the programming language, the prerequisite that we talk about is the Python, right? So Python is something which is very very important language. You should be learning this particular language. It is pretty easy to learn, and apart from that, you should also know the basics of SQL. It may be you find that this is not at all required at the initial level, but as you move towards the ladder to the other upper parts, you will be requiring this particular SQL, because certainly when you reach here you have to use all these things, and you have to work with the data, you have to select the data, you have to push the data and all that stuff. So here you have to work around with the SQL, and sometimes the variation that is HQL, right? High level query language that you have to. Then there is a requirement of some of the data science. Not exactly you need to go into the statistics and all that stuff, but you should be able to organize your data. So Panda is the library which you should be working with. Scikit is the another one, and the NumPy. So these are some of the frameworks, and the data visualization part is also required, right? So all these particular set of libraries you should be looking at, right? You should be practicing them. So this is the first step. If you're not good with Python or SQL, I would not say good. You should be able to write code by using these particular programming constructs. So if you are able to write program, simplest program, it's okay. You can actually go and look at the code. At least you should be able to understand the code. So that much proficiency is required. I always believe that as a programmer, you can learn new programming languages. The only thing which you need to take care of is the syntax and semantics corresponding to that language, because loops are always same. Your conditional structures are always same. Control structures are always same. With variety of different syntaxes, each programming language has few data structures might be added or deprecated from each programming language. So if you know any of the other programming language, you will be very quick on learning Python, and then at least you should be able to understand the code. That is what I wanted to put a point here. Now once you are through with these two steps, you should be I never say that you should be expert in all these particular set of APIs. You cannot, right? Even today, it's almost 1.5 years I have been working with the machine learning. I know which particular API I can use, but I do not know each and every function, right? So whenever I need to do any particular specific task, and if I'm not aware about that which function is going to work around, I just simply go to its documentation, look at the API, look at the function and what parameters are required. Does it suits my requirement or not? If it doesn't, I just override it and work it around. That's it. So this is what you need to learn. So NumPy is something which is required for the scientific calculations. Scikit is another. Then there is a visualization library and the pandas library, right? Panda also contains the visualization part, so that you can also work around. Then comes is, now once you are able to, now this particular part is with respect to data management, right? That is data management. This is basic programming. So that is what is being required. So programming, then data management, and once you have data management, so if you look at the step, defining the problem statement, that's okay. Preparing the data, that is done by Panda, NumPy, and all that stuff. And you can visualize the data, and then you should be looking at that, okay, to which particular algorithm shall I be feeding it, right? So that has actually been brought from the scikit and the keras. So this is where uh, you are actually going to work around with your particular implementation stuff. A lot of already coded algorithms are being provided here in the API. You can directly use them. You just only need to provide the data as a parameter to them, and then all the things are being done by this. So sklearns or scikit that are used for the applied based things. Whereas if you wanted to go more advanced, you wanted to use a neural network, then the keras is one of the best libraries I've ever used, right? And this actually gives you an opportunity to work on your hands-on capstone based projects, if they any are there in your course, if you are studying in your engineering or master's course, or you can do your test project as well, right? So once you are through with this, once you know what is the programming language, it's not at all that you need to use Python. You can also go for the R programming language, right? So which is pretty advanced in terms of data science based implementation, right? So once you are through with the data science with the Python, managing the data management part, and then you are through with the algorithm implementation, then it's the time to move further the ladder, where you are going to work on the big data, and that is by using the Hadoop, Hive, Presso, or AWS. So it's this becomes then pretty easy once you are through with these three steps. It's pretty easy to understand all these particular set of things. Or you can also go for the Spark, or the Scala, or the other real-time deployments, right? So this is what you can actually go through for the real-time implementation. So this is where you are actually going to deploy your models, right? And you are going to process the real-time data to this particular model, and then you are going to do the prediction, real-time prediction corresponding to the various kind of things. So this is what you have in terms of all your path. Apart from this, I am very 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 big advocate for the Kaggle platform, right? So let me take you to the Kaggle platform. So this is my Kaggle platform. It's the demo platform which I have created for you. You can see I've joined it 4 years back by using this particular account, but nothing has been done. But the important point, or the thing which I wanted to make out here, is that uh, the step gathering the data from various sources and cleaning the data. So data is something which is very very important for your work. So if you are looking for the data to work with, this is the place where you can actually go and look around. So a lot of data has been available, different kind of data with respect to hospitals. Right now COVID is at boom. Hotel booking is there, Netflix movie and TV shows data is there, Russian passenger air service data is here, right? The Ebola's outbreak data is there, credit card fraud detection is there. So a lot of different kind of data is there which you can actually utilize, right, corresponding to that particular part. Now very impressive part, what you can look at is, let's say if I'm going to work on this particular data set, and I'm going to download and utilize it for my practice purpose, you can actually see that they also define the tasks for you, right? So these are some sort of problem statements which you can consider, right? So this is the place where you can actually go and look at the problem statement. Then there are kernels, right? So people have worked around this particular data set, and they have actually submitted kernels. Kernels is nothing, is the piece of code that these programmers might have written, and they have published it with the description corresponding to the work which has been provided over here, right? So this is the case study which has been given corresponding to this particular set of data set, and this data set is, I think, COVID-19 case study analysis with and visualization and the comparisons what they have done corresponding to the data which has been provided here, right? So you can actually look at that what visualization it has done. There is no code which this person has provided, but yes, this is something which you can actually see as a sample input, right? So they have given you all these set of things. So they have provided that what sort of input has been provided to this particular notebook and so on. So similarly, if you look at the data again, and let me take you to the another part. Let's say we are going to look at the, let's say, this hotel booking demand, right? So when we are looking at this hotel booking demand, you can actually look at the task. The data description is given over here. The tasks are being provided, that can we predict the possibility of booking, and the kernel corresponding to it has been provided over here. So if we look at this particular thing, 5 hours ago this person has shared this particular kernel. So you can see what exactly this kernel is going to give you around. So it gives you information corresponding to what is being done in this particular set of notebook, and you can see what set of code does this person has used, and this is what has been utilized. So if you look at this particular part now, if you are aware about some of the basics of the Python, so it has imported the pandas library, it has actually read the CSV file that has been provided with this particular data set. So let me take you back to the data set itself. uh, so this is the data, and if I take you down, this is the file which has been provided, that is hotelbookings.csv. Now let's go inside the kernel itself. Now this kernel is nothing, it's a Jupyter notebook. I will show you what that Jupyter notebook is. So once you see the data processing part it is going to do, and it has imported the pandas, it has read the same CSV file, and then it has actually looked at what are the keys which are being available in this particular CSV file, because it has been added through the panda instance. Then it looks at the shape. This gives you the number of column and the number of rows. Then we can describe the data, that okay, overall what is the basic statistics which has been there corresponding to each column set, right? So that has been provided. Then the information info it has published, then a visualization is being done by using a matplotlib. This is a library that has been used, and the cbon it has used, and a histogram and the corresponding storytelling has been done. So this is where side by side storytelling has been done corresponding to this particular part. Then certain more histograms have been generated to each particular set. Then density plot has been provided, and then some cleaning of the data has been done, because we know if there is anything which is empty, we should not be using it. Either we should be dropping that particular row, or we should be putting in certain simple data in that. Now comes the categorical or numerical part that has been done, and so on. So this is the set of example which you can actually go and look at for anyone's submitted kernel, and then you can start working corresponding to your particular set of problem statement solution, right? So here you can see that the model selection is being used as grid search CV. So this is sklearn library that we were actually talking about at this particular place. So this is sklearn library that has been utilized, and it is going to use a grid search CV corresponding to it. And if you look at the above part, so a pipeline has been generated, and a standard scalar pre-processing pipeline has been created corresponding to it, where the different kind of scales has been generated corresponding to different set of methods, right? And here itself the model has been selected for optimization part, and that grid search has been provided with the number of parameters, right? So this is the n neighbor number of parameter which has been provided, and the k neighbor classifier has been used over here, right? So this is the beauty of these kernels, that you can actually go and look into this particular set of uh, code, and then you can also start designing your solution to that particular problem, right? So this is where you should be looking into as a beginner. And one of the most beautiful things which Kaggle gives you is the practice part, right? So this is what is there, the courses which they provide, they are free of cost, so you can actually go through any of these courses as per your interest. So as I've told you that you should be looking into the Python and the corresponding data visualization pandas and the feature engineering part. So you can actually go through all these courses one by one. You can see I've completed the Python course, I've completed the introduction to machine learning. And if you wanted to see what exactly is there, this is what they help you out. They give you certain tutorials and corresponding exercises which you wanted, which you are supposed to submit so that this task gets completed, and ultimately it is going to help you out in building up your skill, right? So if you're not aware about the Python, how to use that particular construct, everything is here, right? So this is the best portal to start as a beginner. Start working on the course. So if I give you a step by step part, start working on these course first. Side by side, you can actually go and look into the data. Okay, and whichever data you are trying to work around, that you can you can go through. And once, let's say, you are going to look inside the data and you are trying to work around it, you should be looking into the kernel of the other persons, that how they have actually worked it around, right? So what sort of implementation does they have done? Okay, so anyone's public code can be actually utilized, right? So this is the piece of code they have done. So if you are worrying about this particular section, please do not worry about it, because this is only the text they have given just to give a storytelling part of this particular implementation, right? So these are the sets we can actually move on whenever we wanted to, move from one section to the another section. So this is what you can actually utilize for your part. And if you wanted to make changes to this particular kernel, you can simply copy and edit, right? So once you do a copy and edit, you will be able to make changes to this code in your account. So this notebook will become your. You can also take part in discussions, which is over here. They can be general discussions, or they can be based on the data which has been uh, which on which you might be working on, right? So this, let me take you back to the data itself again. So here so this is the data set of this data police shooting, and you can actually see the discussion board over here. So any discussion board you want to join in, you can do it here. Any activity you have done or other people have done, that has been provided over here, and any other metadata, that has also been provided over here. These are some of the things which you should be definitely looking at, right? So this is the right platform where you can actually go and start working around, and it's pretty easy once you are done through this. And maybe if you have plans to, let's say, work on this particular data, then you can simply go to this particular right hand side section, click on new notebook, and this will open up a new notebook in your account corresponding to which particular language you wanted to work on, Python or R, depending upon what you have. And you wanted to work as a script, you wanted to work as a notebook, or anything else if you wanted to attach to it. So right now we are going with the default. So once you are done with that, you will be able to get your notebook ready in couple of seconds or minutes, right? So this is what is there corresponding to the usage of the Kaggle based system for your work. So if you expand this particular right hand side portion, you will see the input data, right? And you can see what setting you can use. You can use the GPU and TPU as well, and any sort of code help if you require, that is also available here. So these are some of the basic instructions which are there corresponding to your kernel, right? So you can also rename these kernel as per your requirement. So this is what you have in terms of the Kaggle platform, where you can actually go and get started with the things, right? So this is very, very important for you to at least get started with your learning skills. So first is you go to the course, just complete the courses so that you get familiarized with different kind of concepts. Like SQL is there, uh, Python is there, introduction to machine learning is there. Then you should be looking into the pandas, and then you should be looking into the particular feature engineering, data visualization, and this will allow you to do a pretty good performance on the Kaggle based system. And once you are done with that, you should be going and looking into the data. Takes one of the simplest data for your part, maybe a, I think, Titanic data set is very popular here. So this is the very first problem which people solve. So the Titanic data set you can actually work around. You can look at the kernels. This is not the exact Titanic data set which is there, but yes, you can actually look around the kernel and then work around with your implementation by using the new notebook and the solution which you are going to work around, what you have learned from the courses, right? And then any notebooks which you have created, that will be provided under this notebook. Any competition which you are going to participate, they have been provided over here. And they are also having certain prizes as well. And I think that's it right now for the Kaggle. And let me take you back to the presentation again. So here we are at the end of the presentation part. So this is the end of the webinar almost. And we, if we look at this particular slide, it's not only the machine learning is which is related to the data cleaning and all that stuff. You are actually looking at all these set of domains under this particular machine learning part. So data mining is something which is there. You can generate your algorithm, you can do the classification, you can do the learning, which could be supervised, unsupervised, or reinforcement. You can do the neural network part, deep learning, AI, and autonomous things. So all these things are actually being under the umbrella of the machine learning part. So in fact, AI is not exactly, it's a superset, but yes, it's a part of it. And definitely this machine learning is the future. So if you are still only considering that shall I go for the machine learning or not, you should definitely go for the machine learning. This is the future, right? Nobody knew that JavaScript is going to be used in full scale in 2018, 2019, and 2020, right? So uh, this is right now machine learning is on the similar stage, right? So everyone is going to utilize it in next upcoming 4, 5, 6, 8, 10 years, right? So it will scale, and it will scale to a particular level that a lot of current existing jobs will not even exist in the future, right? So machine learning is something which you should be looking into deeply. It's a time to do the practice, right? So this is something, from my experience, I can simply say the more practice you do with your machine learning part, the more it is going to give you a clarity on the different kind of concepts. And it's pretty simple. You should be following this particular chart in terms of your learning, and you should be looking into this particular process for implementation of your problem statement. That's it. This is what is the requirement as a beginner, right? So that is it what I have for today's webinar. And I am now going to look at the queries which you might have put into the chat section. uh, and let's have some discussion on what your challenges which you are facing right now, what other set of questions which you have in your mind. So let's see what we have from your side.
Okay, so we have a question from Kaushik. He says that does it encompasses the data mining techniques, because the steps you told seems analogous to data mining techniques. Kaushik, yes, of course, the data mining is definitely there, because see, machine learning is more about implementing the specific algorithms for a specific set of problem statements, right? So that is what we have, but that algorithm or that procedure requires data. Okay, and when we say data, the data should be in a specific order so that it can be analyzed without any issues, right? So the machines are working on the basis of data. So if the data is not correct, then how we are going to expect the accuracy from them, right? So you have to actually do the specific uh, data cleaning and data pre-processing before actually submitting it to the particular specific algorithm. So if you have seen that one of the kernel which we discussed on the particular set of Kaggle platform, you can see the KNN classifier was used, right? So the KNN classifier was actually being fed by a particular data pipeline, right? So data pipeline is something which is very, very important for that particular set of algorithm. If you are not creating the data pipeline where you are selecting the specific features, you are cleaning those features, and then you are putting it into the algorithm for the specific further classification. So it's not only the KNN algorithm which it has implemented. There are other ensemble algorithms which are being used over there as well. So the point comes is that the definitely some data mining techniques are required just before, because the data is huge, right? You cannot fed everything for the training purpose, because there are two things which you should be understanding when you are working with the machine learning part. There is a training data set, and there is a test data set, and then there is a real time data set which it is going to work around. So training is something which you choose very carefully. You clear or clean it very carefully. You make it very structured so that the model can be trained and the accuracies can be increased. And then you test it corresponding to a portion of that particular data, clean data, and then you actually throw it to the real time data so that the predictions can be done. So it's a huge process, right? So generally, as a beginner, you will take around 2 to 3 months. uh, that is again a very optimized time I'm saying right now. But yes, that is what you should be considering for yourself. So practice is something which is very important for this particular set of learning. So I hope, Kaushik, I have answered your question. Anyone else who wants to ask any other query? Kaushik, I hope I have cleared your doubt. All right. So any more queries you have? So still, I think there is no more queries from the viewers. Let me see how many viewers are. Oh, there is only one viewer, right? So I think all the viewers have left since I said this is the end of the webinar and all. Anyways, so this is what I have for this particular beginner session. I'm sure there will be one or two more webinars or videos which will be subsequent to this particular webinar. So if it is videos, I'll send it directly to your email and you can go through it. And if it is a webinar, I'll post it again to you because you have already opted or registered for this particular webinar. So you will directly get a request with the link which you can access for the subsequent webinars which are going to happen, or maybe the videos which I'm going to post. So that is what I have. So in the meantime, if you have any kind of queries, you can put in the chat right now. After the video is or webinar is over, you can put in inside the comment, or you can also send me an email on hello@superwits.com. And you know uh, I entertain request for the trainings as well, which are corresponding to Python, Java, C++, or the databases and the machine learning part. So you can directly shoot a mail for that particular part. So I'll be happy to answer your queries. I will be happy to give you some kind of training program if you are interested in. So that is what we have for today's session. Let me see the chat section again. Is there any other query? No, there is no query. So I think that's it for this particular webinar. I think the queries are over, and the objective is almost achieved for this particular webinar, which I wanted to convey to you, that how you can get started, what is the basic understanding which you should be having. And very specifically, I was very curious to share the Kaggle platform with you, that how it can help you out in working around as a beginner to the machine learning. So I hope you will be able to practice corresponding to what we have shared today. And I would love to hear your feedback. You might have received the email, or maybe you will receive it in another 10, 15, 30 minutes. So I look forward for your feedback for this particular webinar session, and that will help us to improve in preparing the content for all the upcoming videos or the webinars that are with respect to the machine learning itself. So that's it. Thank you very much for watching, for all the patience you have kept for around almost 55 minutes. And hope to see you in the next upcoming series of webinars. And for that, you should be subscribing to my channel, as well as you should be clicking on the bell icon so that you get the notification whenever I go live or whenever I post a new video for you. So thank you very much. That's it for today. Bye bye. See you in another webinar or video.